Yes, it works. Okay, young scientist, smiling. Yes, you are a young scientist. You came to the college, you start building your ability to solve critical problems in chemistry and science. So, first of all, I'd like to welcome all of you guys in my organic chemistry class. I hope you will be comfortable learning organic chemistry with interest and fun. And I'll do my everything best to help you out, make sure you are comfortable in learning and success. My classes, I feel that classes are kind of my family, and each one of you are my family member. So again, I welcome all of you in my class. About me, my name is Mohammed Mujibul Haque. In more about me, I finished my bachelor and master's from Bangladesh in chemistry and physical chemistry. In PhD, I came to US, United States, in University of Wisconsin, where I finished my PhD in bioorganic chemistry. After that, I came to Houston. My families are here. So I moved to Houston, started teaching University of Houston system. After 1 year, I got a position, University of Texas Medical Branch in pharmacology. So working on disease and health, mostly cancer research, and I did my postdoc. Then I just moved here, Sajjak. Since UTMB is here, so actually I've been teaching always evening classes around the schools. So now I'm teaching full time in Sajjak, and I'll be your professor for the semester. So I'd like you to ask yourself, what do you imagine about chemistry when you hear the word? What comes in your mind?
Cooking with chemicals.
Cooking chemicals.
Reactions, thermodynamics.
Thermodynamics, okay. Reactions, cooking, thermodynamics. Someone from this side?
Stoichiometry.
Stoichiometry. I was scared about it when I was in undergrad. It's good you mentioned that word. So that means you are a standout. Someone from behind? Yes. Endothermic, ectothermic. Someone from this side?
Hydrocarbon.
Second?
Hydrocarbon.
Hydrocarbon. Very good. He touched the word that we are going to work on. You see? Remember earlier I said young scientist? Okay. This perception that you said, laboratories, chemical reaction, stoichiometry, that's the common perception about the word chemistry or organic chemistry. But that's not all about chemistry. And whenever you hear organic chemistry, that's going to be more intense, more scary, more fearful, isn't it? What I've been hearing in my life? College chemistry is boring. Have you heard that? My teacher said I will never be good at chemistry. Yeah? No matter how much I try, I never pass my chemistry test. People say like that. So, and if you go to medical school or pharmacy school or any of the medical field, you need to get A in organic chemistry, right? You must get A. But organic chemistry, unfortunately, people consider as the barrier of their success. As you see the pictures, they're walking, and this is the obstacle on their path. And this is very common. And this universal concern are a growing fear, not only in the school, beyond the school campus, it is spreading, it is a growing fear. So my goal is to break that barrier. My goal is to understand that anybody is able to work hard and anybody want to achieve this critical organic chemistry science, it is going to be achievable and rewarding and enjoyable. If you see around the world, sky, stone, nature, our human brain, look at the air, full of chemicals, full of oxygen, carbon, nitrogen, carbon dioxide, water vapor. Look at the fire, combustion of carbon and hydrogen. Human brain made of fat and some other element. Look at the DNA, human DNA, made of simple, nothing but a carbon, hydrogen, oxygen, nitrogen, and phosphorus. And if you see the air full of chemical, if you see the water H2O, see the plant, which is chemical factory to producing oxygen for us, right? And if you see inside the plant and living animal, what do you see? Protein, DNA, RNA, ribosome, right? All chemical. So chemistry should not be thinking like laboratory experiment, carbon, hydrogen, stoichiometry, just measurement, and then that's not all that. Chemistry should be thinking as human body, nature, DNA, how food is digesting with millions of billions of reactions, how this periodic table making everything as a single component, as a single element, making everything in this world by this our catalog, which we call periodic table, right? Chemistry should be thinking as when you drink alcohol, how it is affecting to our brain, lung, liver, like that. So everything in the world around us is a chemistry. Chemistry is a wonderful world of science to dealing with nearly infinite number of chemical interaction take place around us. That's how you should think. Also, how about you think that way, like a Lego? You don't know what giant and interesting thing you can make by looking at a box of some Legos, right? When you make it, it's giant and something critical and interesting and big. Organic chemistry is like that. You're learning single tiny things. As semester goes, semester ends, you're learning a lot of things together as a big giant organic chemistry, and that is going to be rewardable and interesting, as I said, fun as well. Because everything is connected to human body. Everything is practical. Everything is whatever happening, interactions around us. See? Let me give you a few more perception around the society about the organic chemistry and their words. How the word, I can ask you yourself, how you feel the word chemical? Think about it. Very bad,
Yeah.
harmful. What else? Dangerous. Exactly. Something you make in the lab, that is dangerous. Oh, it made in the lab is chemical. So imagine these people really get chemical-free food. No oxygen, no water. They become a statue or dying of not having oxygen to breathe, not water to drink. Let me get one more word. natural. What do you think? Amazing?
Clean.
Clean?
Yeah, healthy.
You guys are amazing, actually. What else? Healthy, right? It doesn't mean anything. It doesn't mean healthy or toxic or natural or good or bad. It could be, this natural could be good or bad or nothing. Right? Yes, it could be delicious, it could be healthy, but it could be healthy, it could be delicious but toxic. Look at that. So these words are hijacked from the real meaning that we chemistry have been using for. We science have discovered this. And chemistry, organic chemistry, you came here, is kind of new language for you from the society. Society treat this wonderful, very common and important word as a wrong perception. But you learning as a new vocabulary using in a different way. Look at this tree. Is it natural tree or chemical tree? It's natural. Of course natural. It's coming from nature, right? This happened to be, the name is hemlock. This tree have a big interesting history. Is when Socrates was being hanged, being sentenced for polluting youth, he was given this juice to drink. And guess what happened?
He died.
He died, you're right. That was 100% natural, isn't it? But he died. So someone asks you 100% natural, think about it, or remind him that the fate of Socrates had. Again, so chemistry contribution is huge in the human generation throughout the history. You name it, any medication, any drug, cancer, immune system suppressor, antibiotic, diabetic, you name it, Parkinson's, Alzheimer, whatever you think. Most of the medicine discovered by chemists, organic chemists. I'm not disregarding the contribution of medical doctors, but think about it. Without this medicine being discovered, how the doctors would be treating their patients? They would be only maybe diagnosing their diseases and treat with what? Hands and bones? So think about the level of organic chemistry. Everything you can imagine, every second you're using, your fabrics, your pen, your thinking, your talking, your body is chemical factory. Reactions going on in your body. When you're eating food, that every single molecule is reacting in our body in different way. As body is full of chemical industry. Look at the food. Is it good food or bad food? Tastes good, but what's bad? We all good.
I mean, the trans fat.
Trans fat.
I mean,
It's
She's right.
I mean,
So everybody knows that. Who doesn't know that? That junk food is bad. Who doesn't know that? Everybody knows that, right? Tell me one single person in my whole class that did not have junk food today, whole day. What did you eat? I'm proud of you. I'm trusting you. Just
I had sweet potatoes, which I consider kind of junk food, and then that's like my
sweet potatoes, rewarding. It's a rewarding carb. Okay.
egg whites, and then for lunch I had chicken and broccoli and cauliflower, and then for dinner before this class I had a spinach salad.
Sweet. Tell me, which chicken did you eat?
Just chicken breast.
There you go. So, you know that chicken is hormonized, steroid, toxic metals. I'm not discouraging you. This is not the worst one, right? So, good. And if we know that this food is how dangerous, how this junk food come into our body, making our body acidic, lowering pH down, welcoming all the disease, you see? If you understand this science of this biochemistry, how food is affecting our body, and we would not eat that anymore. So it is very important to learn deep chemistry. For instance, our supplement vitamins and drugs, how this helps us or harms us, how our injury, treatment, disease, what kind of chemical process going on. This is important to know to maintain our good health. Chemistry not only for the medicine, it's beyond that. For our fabrics, for our oil industries, for our preservatives. We can name chemistry is a huge contribution around the history for the human generation. Excuse me. So all of you guys are construction worker. As construction worker, they build the tower from a small building blocks, use a brick. The same way we'll be building molecule, solving critical problems from tiny and scratch. And we also work like an architect. We plan and design the molecule. Sometimes we don't have tools, and we discover the tools. We create our own tools to solve the problems, to answer the questions. Think about how rewarding, how interesting it is. You might be thinking, I'm going to be doctor or engineer. What do I need that for, right? Of course, health part, you understand that. What else? The way you solving the problems, this critical development will help you to become a better engineer, to become a better doctor. If you don't know how to write measurement, you don't want to kill your patients with the wrong dose to you. So, look at this picture. What I want to talk to you about this is every second, every moment, or constantly, our body cell is dying, right? Within a certain time. And this cell is regenerating after a certain time. When cells are growing, how it does work? Amino acid comes from protein, so amino acid coming together, glued up by ions and minerals. That's why make sure don't keep your salad or vegetable as a side dish. That's your 70% of your food. If you make a side dish of your meal, I'm talking about the green leafy vegetable, you are going to be struggling when you get old or for certain years, when in my age. Trust me. Young, how many guys? You're like 20s, most of you guys. So when you get 30s, you will see what you did in 20s. So your food have to be, let's simple regional, you understand. So amino acids are glued up by what? By ions and minerals. If amino acid cannot glue up, cell regeneration cannot start. And if you don't have enough iron and minerals, cell cannot grow, but cells are dying. You see some people's face are really fade and sad and dark, and why? Because too many, they're not have enough minerals and ions in their body, or fat. Big misconception about the fat. People hate fat. How many of you hate fat? Everybody, I know that. We have been bombarded with the wrong conception. I know one old lady, I was sitting with her breakfast and lunch. In the breakfast table, she is not eating egg yolk. What happened? She said, fat. Then what are you going to eat? She said, I'm going to be eating cereal. Doctor told me this is good cereal. Think about it. Cereal is a carb. carb doesn't have any contribution our body whatsoever. No. We're putting carb as our main meal. Of course, developing countries who doesn't have opportunity to eat fat, that's a different story. They need to have carb to get the energy. Or someone really tiny, skinny, I don't see any of you, someone really skinny, they need some carb to go to more, more weight. But fat is the one easier contributor to our brain needs 80% of fat. Our cell membrane needs 50% of fat, you see? And fat is giving you double energy than carbohydrate does. Which one are you going to choose? Think about it. Fat. But I'm not saying about the junk fat like we have been taking chicken and then or cheese and stuff. I'm talking about the real fat. Avocado, coconut oil, olive oil, flaxseed, any of seeds, all nuts except peanuts. You see? These are the real fat I'm talking about. Anyway, go back to our topic. So, and this amino acid, which is cell growing, is nothing but a carbon hydrogen. That means hydrocarbon. That's what we'll be studying in this class. Look at this DNA, which is transferring our generation to generation. What is made of? Made of carbon, hydrogen, oxygen, nitrogen, and some phosphorus. Look at the carbohydrate, that's what we love to eat all the time. This is our main dish, So, what is made of? Carbon, hydrogen, you know that. Carbohydrate means carbon, hydrogen. Look at the other one, all the medicines. Similar. That's what you're going to be studying. So, make sure when you study organic chemistry, don't take it as a passive, finish it as quick as possible. Take it as a rewarding, something deep and real science to learn with interest and fun. Success should come with enjoy, the rewarding. That's really, really much sweeter than success with a hardship. Of course, I'm not saying organic chemistry is very easy to learn. It is not hard. It is just need some hard work. That's all. So, all I say, you should not look at as this is, remember earlier I showed a picture? The kids are looking at their obstacle. Don't look at that it is your obstacle, or don't look at that it is your barrier for your success. But if you, let me show you if that is the case, that's a different story. If this is the experience from the person who did this blundering mistake by this smart man, or someone went through their anxious time entering medical school or entrance exams, that experience is transferring to you, you should not buy that. You should think that this chemistry is neat for your day-to-day life, this chemistry is enjoyable, rewarding, and it is achievable. So the last thing I want to show you, our human body. As I said, this is a living periodic table, right? So this chemical industry producing millions of reactions every moment, as you can imagine. If you zoom in, whole human body is nothing but a cell. Different types of cell from different types of organs. And so if you zoom in more into the cell, what do you get? Mitochondria, ribosome, DNA, RNA. For instance, DNA, which is two strands connected by chemical bond. And these two strands made of nucleotides. If you zoom in more, nucleotides. And each nucleotide is made of carbon, hydrogen. My PhD was in DNA chemistry. So it was so interesting when we made DNA in the laboratory, which is just simple carbon, hydrogen, and nitrogen, oxygen, and some phosphorus. So this is another presentation of DNA. And look at this picture. This is my PhD defense slide. Look at the molecule. Simple molecule connect to DNAs, two DNA strands that kills the DNA. So if we use this chemical in a cancerous cell, this DNA cannot proliferate, cannot grow anymore. So cell dies. If cell dies, cancerous cell cannot go their abnormal growth. So that's how you treat the cancerous cell. You're treating the cancerous patient. So go back to organic chemistry again. So in 18th century, organic chemistry was thought that it is only found in living animals, living things. It is only biological molecules. And people thought that organic chemistry is, organic compounds is a mystical compound. It cannot be created. It cannot be seen, cannot be found. Until 1828, German scientist Friedrich Polar, he discovered that he simply heated ammonium cyanide and then he made this urea. Then that's the first time people found out that organic chemistry, organic compounds is nothing but carbon, hydrogen. So that's the actual organic chemistry is. We'll be dealing with the carbon, hydrogen and their subparticles, their groups and their other atoms. So mostly carbohydrates and their other molecules will be dealing in organic chemistry. And then in 20th century, people started making more organic molecules like methane and ammonia can make organic molecules. And after that, we have been discovering all the drugs and pharmaceuticals and all preservatives, all chemicals we have been discovering in the laboratory from any other chemicals. So our body, carbohydrate, fat, amino acid, DNA, all of them nowadays are made in the laboratory. So to be success, as I said earlier, that organic chemistry is going to be new language for you. I mean that it is going to be new grammar, new vocabulary, new sentence making, new concept, of course, and you just need to be working on it. And organic chemistry, we learn three things. First of all, stereochemistry. You heard the word stereochemistry? Did you hear the word? No? Stereochemistry is how molecular look like in a three-dimensional shape. How they are rotating, how they are located in different atoms in different sides. We're going to be learning a lot of functional groups. Functional groups means the groups is identifying, determining the property or reaction of that compound. So if a molecule has a weight, we can tell that what kind of compound it is. So if we have a CHO, we can imagine their property, how they look like, how their property, how they are going to be reacting with the other molecule. So second thing is functional group. The third thing we'll be learning in organic chemistry is the reaction, which you already expect. We're going to be learning a whole bunch of chemical reactions from, from organic, inorganic, all types of molecules. And so how can you be a better learner? The answer is very summarized in here. So you have to read before the class. You have to read before the class. Let me check it.
You failed.
Okay, so you read before the class. There's a tips for learning. And you come to the class with a pre-assessment. Have you heard the word pre-assessment with any other courses? Pre-assessment is you making summary of the chapter before coming to the class. So, for instance, next Monday would be your first chapter. You'll be reading out the chapter and write out the summary of the chapter, the theory, example, chemical reactions, compounds, as you like, as you feel is a summary. But first lecture, of course, I'll give you the feedback. So you should be good with that. I'll give you feedback, it will not be graded. So the point I made that you studying before the class, not coming to the class, I'll be learning, no. You study them up, come as if prepared of learning. As you know what kind of thing you're going to be learning in this organic chemistry. It's not a story that you hear a story and answer some quiz and get the grade. That's not the way it will be going. And when you go home, you rewrite your notes. The class, you sometimes scratching, sometimes you writing, scribbling, and then quickly go home, make your fresh note. Make a special notebook. This is the class notebook. And I'm going to be looking at it. I'm going to be, I will be wanting to show me that how you're writing your class.